All right, good morning or good evening, depending when you're doing this. The objectives said I can study projectile problems by dividing the event into two axes. I can identify three variables in each axis and solve for the missing quantities. I can use time as a communication between the two axes. I can apply the Pythagorean theorem and solve for the resultant velocity. Plus, you got to find the angle too. All right, so part A, write the equation, find the variables, show work, then fill out the chart with all the values for the variables. Part B, draw the diagram, label calculated parts. Okay. Professional stunt driver, Mrs. Nagel, that's my cool car. She drives at 30 meters per second off the top of a horizontal cliff that is that height. All right. So first thing I always know that even though my car kind of goes like this, like that to the ground, that it has a velocity in the x-axis that like never changes. The arrow should always be the same. And the velocity going down, so it's going down. The little velocity is going down, goes that, and then a little faster, and then a little faster. So it took like little snapshots. These arrows increase in length. These arrows stay the same. All right. So what's that mean? Zero acceleration in the x-axis. Even though it's falling to the earth, it doesn't accelerate horizontally. Unless there's like a car explosion or something like that. Right. Gravity is always 9.8 meters per second squared. All right, what else do we know? Well, we know the height, and that's the height vertically. So I put that over here. 78.4 meters. Then you're like, all right, well, what else do we know? Well, she horizontally came off the cliff at 30 meters per second. So I put 30 meters per second. And this never changes, so it's also the final. And according to the rules that Mrs. Nagel keeps singing about, happy no, find three things. 1, 2, 3, I should be good to go. All right, so now I put the stuff in my equation. So I look at my equations right here, but I got a problem. Acceleration never accelerates horizontally. It only accelerates going down. Because remember, breaking into two parts. That's zero because A is zero. A is zero here, so half times zero times a t squared, that becomes zero. And all this becomes zero because that's zero. The 2, the A, and the D become zero. So now I have V and final equals V initial in the x-axis. Oh yeah, that's obvious. And then I look over here, V final squared, square that. Will that equal the initial square? Yeah. Oh, that didn't get me. So this is the one I gotta go for. If you look, I don't have T and I don't have D. So that little rule, 5, 3 things, doesn't work here because it ends up being a loop around. And now what I do? Well, go to the y-axis. So this is where you start. So start here. Woohoo! What else do I know? Well, as this car kind of drops, as soon as like the car goes over the cliff, speed trap. All right, when it goes when it gets off the cliff, I put cliff around here. Guess everybody goes off the cliff. It starts to drop and it starts to move this way. So it has a projectile path, vertical axis like that. All right, so that initial, just like dropping an object. So oh, there's your 3 things. Now, if you read the directions up here, it also says you gotta, like, it's the time that's the most important. So up here, I can use time as a communication between the two axes. Mrs. Nagel, right? All that stuff that I probably didn't read. All right, let's find V final first, since we've got to fill this whole chart out. So look at my equations. That's the back of the reference table too. V final, oh, I don't have time, so that one's no good. That doesn't even have V final. I use that one. V final squared equals V initial squared plus 2AD. V final is unknown, so we're going to find that. V initial, the goose egg, plus 2. What's gravity, or A? Negative 9.8 meters per second squared. What's D? That's the height. Oh, oopsie daisy. That's going down. Pick myself up. Okay, oopsie daisies right there. Forgetting that negative, that would be painful because then I'd get like this weird square root. That just screwed me out of calculator. Well, I better pause that video. Hold on. Okay, so here's my calculator. I'm going to plug this in. So I can rewrite it as this is out. So it's really like 2 times 9.8. Oh, I'm not using units. And then negative 78.4. Just trying to like simplify things, make it a little easier for you kids, you folks at home. So I put in, I know a negative times a negative is positive. I don't even bother reading that. 2 times 9.8 times 78.4. So I have V final is this like huge kickbutt number. Well, this is the y-axis. Put that down. That's so I don't have to write all these little y's underneath here. All right, we got 1536.64. Now how to get rid of the. How to get rid of that? Ugh, where's my pink pen? Darn it. Ugh. Well, I was gonna bring a pen, but I'm gonna use square root. That looks a little different. Probably not to you guys, but whatever. Square root of V squared. V. Now hit the square root. Hit the second x squared button. And then I hit second answer. And that gives me 39.2. And then my units are meters per second. Done. I'll put that on there. And oh yeah, we're going to choose downwards because remember this comes out plus or minus. We choose down because the car is falling down. Downwards. All right. Downwards. So negative because we're going down. Again, that's plus or minus, plus or minus 39.2 meters per second. Now I got to find time. V final equals V initial plus AT. Find time. Time. Finding time. I can't spell. There we go. Find time. Time. So V final, now I know is negative 39.2 equals, that's a big goose egg, so it's dropping, plus negative 9.8 T. Rewrite it one more time just for goofy fun, clearing that up for kids who are a little slow in their algebra skills. Oh, I'm trying to block pen right now. Now get rid of the 9.8. That's actually multiplying by the T. So divide by 9.8 both sides. Those cancel out. Now you're left with 3.92 is equal to T. So put that in. Divide by 9.8. Sorry, put that in. Clear. I'm not going to put negative because that negative and that negative cancel out to be positive. So I'm going to put in 39.2 divide by 9.8. Oh, that came out really nice. 4 seconds. I thought that was a black pen. Whatever. Fooled me. It's blue. So that's actually seconds. Don't forget that's time. Put 4 seconds. All right, now according to the rules, right up here, remember, I can use time as a communication between the two axes. So this is the same. La 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 la. Now I can say 4 seconds. Oh my goodness, we're almost done. Ooh, yeah, ooh. Now I can plot that. That's the only really equation in the x-axis. Just this one. And that's just like info. So where am I going to write that? So I'll write it over here. Now I'm doing x-axis. And I'm going D equals VT. It's actually V initial, right? So now I write D is what I'm looking for. That's the range. Or the distance that it traveled in the x-axis, horizontal. And that's right here. That's this. dx. From here to here. It's dx. This is the dy. Say it. Hurry up, Mrs. Nagel. All right, let's go. I'm going. I got 30 meters per second. Times my 4 seconds. My displacement range is 120 meters. She went like a football or anything. Woohoo. La, 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 la. Filled out the chart. Yes. Then you know it should be done. Nope. Because now we got to bring everything together. That's just the clip going off. It's just the car going off the cliff. Now I got to look at the crash site. What's going on? I got to combine these velocities. Not a lot of room. We're going to do what we can. So we got this like car comes in. It's like it's a crashed car. Whatever. All right. I don't have a lot of room. Oh, I should jump over there. But all right. So that's a car. Comes in. Hits, right here, it has 2 speeds that we're going to bring together. It has the 30 meters per second here, and it has the negative 39 meters per second here. Well, it's like 0.2, whatever. And I've got to find that arrow. So what I do is I bring this over. I'll look for my pink pen. Okay, so I did get my pink pen. See. So what you're going to do is you're going to bring, to figure out the combining this velocity and this velocity together, you take your imaginary arrow and you slide it over here. Because then you have the head of this arrow, that's the head of the arrow, touches the tail of the other, or toe of the other arrow. And so the resultant, so you combine that one and that one, actually goes right here. That is the resultant velocity. Resultant velocity. So your actual picture ends up looking kind of like, I don't know. So you have this 30 and 39.2, something like that, yeah. And then you're trying to find that. That's Pythagorean theorem. A squared plus b squared equals c squared. And when you find the c, that will be the combined velocities. Those are like meters per second. So we'll put that in. We put c squared equals 30 squared plus 39.2 squared. Calculator. So now I write c squared equals, I put 30. I see this, 30. I hit that button, squared, plus 39.2. I hit that button again, squared. You don't really have to write this number down. I would just square root it, but just for clarity's sake. La la la. Now I got to square root both sides. See, there's a c squared here equals that. So here. Technically, the unit was like a meter squared a second squared, because the 2 goes into all the parts. So when you square root both sides, you're going to get a single velocity. All right, so when I write c, so when I square root that, I hit the second button. Nope. There's my square root. Hit the second. And then like above that is the square root symbol. And then I have in memory stored, I hit second, answer key. And it puts that number in. And it gives me what's my velocity is if I combine the x-axis and the y-axis. It's 49.4, and the single unit is a meter per second. That is the resultant velocity. The results of the velocity. There you go. That's what Z is. There. Oh my gosh. All right, now the last thing. Oh my goodness, you're not done yet. We gotta find that angle. You guys call it SOHCAHTOA or something. Ugh, so ridiculous. I know another way. I call it Oliver and Oscar have huge ankles. And then I put like, oop, there's an S here, there's a C here, and there's a T here. And what these do, these relate lengths to angle sides. And these like represent opposite over hypotenuse. So this is like if you're looking at that angle, here's your opposite side. And then this is your C is your hypotenuse. And then if you're at that angle, you can use the cosine of that to find that angle. And that would be adjacent, which would be this length, 30, over the hypotenuse, which which is what, 49 right now, right? And then the last one is the tangent. So if I take the tangent of that angle, I can say opposite, that's your 39, over the adjacent, which is 30. So I'm going to use that one. You can use any one to find it, but whatever, just to be consistent. So, all right, the tan of some mysterious impact angle right here. Technically, this angle over here is that angle. There's like symmetry going on. So we're looking for that angle. Equals opposite, which is your 39.2 divided by 30. Technically, there are like meters per second here, meters per second here, and these cancel out. Then you're going to do something called the inverse. You're going to get tan by this. You're going to take the inverse tan of both sides to go inverse tan times tan of theta would be just theta. Then you write inverse tan, and then you put this number in the calculator. 39.2 divided by 30. Here, how does you go? How do you put this? It's really important that you got to do this. Second tan makes it go to the inverse tan up here. It makes the tan to the -1. So I hit second inverse tan. See how it says tan to the -1? You need that because you're flipping. Now I put in 39.2, 39.2. Yep, at the divide. Divide by 30. Simple. And then the angle of impact is 52. I'm going to round 6. 4 or less, drop the miss. 5 or more, up the score. And that is degrees. So that impact angle right there is 52.6. Wow, that's done. Bye, guys. Woohoo!